Let's talk about a few two-level logic variations. So we've talked about ands followed by ors, and this is used for sum of products form, or SOP forms of the equation. And this is the most common form of two-level logic. But there are also some variations. So we may want to produce a circuit for an equation in POS form. Then we would use, well, POS form looks something like this: y equals a or b bar and b or c or something. So this one is a minimized POS form of the equation. In that case, we would want to use ors, right? The first level would be to produce these or functions, or these sums, and then we would follow those ors by anding them together. So then we would have ors followed by ands. And it turns out that we can just as easily use NAND gates for SOP forms of the equation, and we can use NOR gates for POS forms of the equation. So let's suppose we have this two-level logic function. This is now an SOP form of or POS form of the equation, product of sums. So we have a product of these sums. And so now we'd want to use ors followed by ands. So here's our OR gate level to produce the sums of those OR expressions. And we'll put our inputs here, A, B, and C. And we'll put bubbles on these gates. So we're going to grab A bar or B bar. And here we grab A or B or C bar. So we OR those together first. And then we get an AND gate, the second level, and grab those OR terms. And so now we have OR gates followed by AND gates. And to make these purely OR gates, we could, the best thing to do at this here would be to take off the bubbles and put our inverters off of the inputs to get A bar. So now we're going to pick off A bar or B bar, A or B or C bar. And so if we wanted to turn these into a NOR gate only, so right now we have ORs followed by ANDs, but we could turn this implementation into using NOR gates only by putting bubbles on the output there. And from De Morgan's, if we put bubbles on the inputs of this AND gate, that also is a NOR gate, because if we have some gate that looks like this, which we'll talk about more next, and we have, so W equals D bar, D bar, D bubble, and E bar. Well, we know using De Morgan's that is the same as D, or that we're kind of going the opposite direction we usually do of distributing this bar, but this is the same as D or E, all of that bar. And so this gate here is also a NOR gate. These two gates are NOR gates, and this gate down here is also a NOR gate. Just a different symbol for it. And so we can take our original POS form of the equation, or implementation of that POS form of the equation, and put bubbles on the internal nodes, and now we get an implementation using only NOR gates. And here's our two-level logic using, this is our canonical SOP form of the equation, with our ANDs followed by ORs, We use that for SOP forms of the equation. And now if we put bubbles on the internal nodes, just like we did in the POS form, now we have a NAND gate only implementation. So here are our NAND gates, and this is also a NAND gate, a different just form of that NAND gate, right? So if we have, let's say we have a gate with two inputs like this, you know, different circuit here, but y equals a bar or b bar. We know that using De Morgan's, kind of, you know, reversing De Morgan's, usually we're distributing that bar, but in this case, or turns into an and both of these go under the bar. So y equals a bar or b bar is the same as y equals a and b, all of that bar, which we know is a NAND gate. So this is also a NAND gate, just a different kind of schematic version of that. And it's easier for us to see, right? Two bubbles on a wire, those cancel. So effectively, you know, logically, it's still that, because if we put a bubble, invert that output, and then invert it again, it's as if we did nothing to that, to that output, right? The output from this original AND gate. And so now we have the implementation, the two-level logic implementation using only NAND gates to implement our SOP form of the equation. And again, remember, both of these gates are NAND gates, both forms of these gates. The AND shape body with a bubble on the output, or the OR shape body with bubbles on the inputs. And here's another example of taking a POS form of the equation, product of sums form of the equation. So we have our OR gates followed by an AND gate. And if we put bubbles on those internal nodes, again, those turn into NOR gates, two forms of the NOR gate. And remember, this is a NOR gate, and this is also a form of the NOR gate.